Hello, welcome to dimu's tutorials. Let us answer advanced and tricky questions on engineering materials.
Question: how will you justify that steel is more elastic than rubber?
Answer: imagine a metallic bar with 2 mm diameter and 50 mm length is under tensile load of 100 Newton. It will expand in the direction of load and regain its original length after removal of the load. Now imagine that same amount of load applied on rubber bar with same dimensions. Being flexible than steel, it will go beyond the elastic limit and may go beyond plastic limit and will fracture ultimately. Both the bars have same dimensions and are under same amount of load. Steel bar will not expand much but will regain original dimensions after load removal, whereas rubber is not able to regain even after removal of load as it is fracturing. Hence justified that steel is more elastic than rubber.
Question: is it true that higher the modulus of elasticity, more elastic the material is?
Answer: Young's modulus. A modulus of elasticity is resistance to deformation under the action of force. Hence, if any material has higher modulus value, then it is trying its maximum not to deform easily, and even when deformed, not to change lengthwise or try to regain original length. Greater the resistance to change, greater is the elasticity of the material, and the faster it comes back to its original shape or configuration when the deforming force is removed. Hence it is true that material with higher modulus of elasticity is more elastic. For example, steel has higher Young's modulus than rubber.
Question: how ductility and toughness are similar and different in definitions?
Answer: ductility is ability of material to elongate beyond elastic limit to form a product like wire. In tensile test, ductile materials show good elongation in length without stress. Toughness not only considers ability to elongate, but also ability to withstand high stress values while elongations. Similarity in definition is that both have great elongation properties. But unlike the ductility, in toughness stress is also considered.
Question: differentiate between ductility and malleability.
Answer: ductility is the ability of material to elongate beyond elastic limit to form a wire under tensile load. Ductile material have very good tensile properties. And malleability is ability of material to change into thin sheets or deform to thin shapes under compressive loads. Malleable materials have very good compression properties.
Question: explain resilience with an example.
Answer: resilience is ability of material to store energy, while compression attention and release this energy after removal of load. Proof: resilience is defined as the maximum energy that can be absorbed without permanent deformation. The modulus of resilience is defined as the maximum energy that can be absorbed per unit volume without permanent deformation. For example, shock absorbers of automobiles or expansion springs in gun.
Question: what is case hardening and where is it needed?
Answer: in case hardening, only surface is hardened without affecting properties of whole component. Material becomes brittle when it is hardened. To maintain its toughness while making it wear resistant, case hardening is done.
Question: what is the inherent characteristic of material that makes it tough?
Answer: tough materials have ability to extend the possibility of necking under tensile force to eliminate the fracture. Tough material has ability to deform plastically under heavy stress. It has a characteristic of strong bonding in its microstructure.
Question: what is the difference in between stiffness and strength?
Answer. Stiffness is displacement per unit force. Strength is ability of material to resist the deformation within as well as beyond elastic limits. High-strength materials will fracture at high stress values. Strength is evaluated as yield strength and ultimate tensile strength. Stiffness is one of the properties of high-strength materials.
Question: how will you justify that hard materials have good compression properties?
Answer. Hardness is resistance of the material to penetration, or compressive deformation. It is also resistance to abrasion, scratching, cutting or shaping. When material is subjected to harsh situations listed above, it is under compressive load. Nevertheless, hardness is measured by compressing the specimen with diamond tip ball, and penetration occurring at different force values is monitored. Hence justified that hard material have very good compression properties.
Thanks for watching. Log on to dies.biz for more engineering tutorials.